students, welcome to Easy BTech, your guide for BTech and beyond. And our subject is Signals and Systems. And today's topic, Exponential Fourier Series. This topic we discuss now. And before going to our topic, please subscribe, share the channel. Okay, it will be very benefit to you. So subscribe and share the channel. You can understand all the subjects very easily. Let's start our session, Exponential Fourier Series. And already we discussed in the previous session, Trigonometric Fourier Series. So representation of periodic signal x of t by linear combination of harmonically related sinusoids. So in that Trigonometric Fourier Series, what we use? Harmonically related sinusoids. In the same way, now Exponential Fourier Series. Exponential Fourier Series. Exponential Fourier Series. So here also we are going to represent periodic signal using harmonically related exponentials. So in this representation we use exponentials. Hence it is Exponential Fourier Series. That's all. Simple meaning. Exponential Fourier Series. Exponential Fourier Series. Representation of periodic signal. Representation of periodic signal. Representation of periodic signal. Periodic signal. By linear combination of harmonically related exponentials, complex exponentials, harmonically related complex exponentials, complex exponentials. This series is Exponential Fourier Series. Now, how to write this? Here I have given you a statement or definition. The same thing I am going to write mathematically. Whatever we written, the same I am going to write mathematically. X of t is a periodic signal, right? This we are going to express linear combination of harmonically related complex exponentials. So this x of t is written as like c naught plus c1 into e to the power complex exponential. So j omega naught t. And similarly c minus 1 e to the power minus j omega naught t. Both sides I am writing plus c2 e to the power j 2 omega naught t. So this is the harmonic frequency, integer multiple of fundamental frequency. Fundamental frequency is omega naught. So please remember this words, fundamental frequency omega naught, and harmonic frequency, second harmonic frequency 2 omega naught. Similarly left side also we get 2 omega naught. So plus c minus 2 e to the power minus j 2 omega naught t. Next c3 e power j 3 omega naught t, and so on up to infinity. And here also up to minus infinite. So this series is like whatever the definition, the same thing I written mathematically. Nothing new here. So the x of t is periodic signal. It is written or represented using harmonically related complex exponentials. So instead of writing plus 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 up to infinite up to minus infinite, we use summation. We can use summation. So x of t is equal to summation where to where minus infinite to plus infinite Cn e to the power Jn omega naught t. This is called complex exponential Fourier series, right? Or exponential Fourier series simply. So here, as already we discussed, omega naught is equal to 2 pi f is equal to 2 pi by t. T is a fundamental time period, right? So omega naught will be called fundamental frequency. So here I am writing T is fundamental time period. Fundamental time period. And omega naught will become fundamental frequency. And what is Cn here? See here, Cn. Cn means like C naught, C1, C2, C minus 1, C minus 2. They are called coefficients of exponential Fourier series. So Cn is exponential Fourier series coefficients. Exponential Fourier series coefficients. Exponential Fourier series coefficients. So these coefficients we have to find. We have to determine. That is the meaning of exponential Fourier series. You are doing exponential Fourier series means what we are going to do? Coefficients we are going to determine. This Cn. And we have a formula for Cn to find coefficients 1 by t integral 0 to t x of t into e to the power minus jn omega naught t dt. So this is the formula, mathematical formula to calculate or to find coefficients of exponential Fourier series. Let's have proof for this Cn. So how to prove Cn? We know exponential Fourier series. We know that exponential Fourier series. What we know? X of t is equal to summation n is equal to minus infinite to plus infinite Cn e to the power jn omega naught t. This we know as per exponential Fourier series. Now we want Cn formula. So I am going to multiply x of t both sides. Multiply both sides by e to the power minus jn omega naught t. Multiply by this and integrate both sides are integrate. We are talking about both sides. So integrate with respect to t over the limits also important 0 to t or one time period. So let's do this now. So x of t is multiplied by e to the power minus jn omega naught t and it is integrated over limits 0 to t with respect to t is equal to same thing on right side. So summation as usual minus infinite plus infinite Cn also as usual and integral 0 to t e to the power minus jn omega naught t into e to the power plus jn omega naught t dt. That's all. Now if you see right side, if you simplify right side, so here we have Cn as it is I am taking here e power minus jn omega naught t plus jn omega naught t, it will become 1. So integral 0 to t 1 dt. So it will be Cn into t, right? On right hand side we have Cn into t. We need Cn. So send t left side, you get the Cn. So what is Cn now? Cn will become 1 by t integral 0 to t x of t into e to the power minus jn omega naught t dt. This is the formula of Cn, simple formula. Okay. Now from Cn I can write the formula of C minus n also. It is also important. C minus n. How to get C minus n? How to get C minus n? Cn is available. Now I want C minus n. Same formula, 1 by t integral 0 to t x of t into e to the power, here minus, then we get here plus minus n minus plus n omega naught t dt. This is C minus n. Okay. Just remember formula C n, C minus n. Now another point we are going to discuss, relation between exponential Fourier series, I am writing short form EFS, exponential Fourier series, and trigonometric Fourier series. Very, very important. The relation between exponential Fourier series and trigonometric Fourier series. Let's see what is the relation. So relation between exponential Fourier series, trigonometric Fourier series means the relation between coefficients of exponential Fourier series and coefficients of trigonometric Fourier series. Coefficients relation. This is coefficients relation. Simply, we talk about coefficients. Okay. Coefficients. So first I go with exponential Fourier series. I will consider exponential Fourier series. We know exponential Fourier series. What is exponential Fourier series? X of t is equal to summation minus infinite to plus infinite Cn e to the power Jn omega naught t. So here we have summation from minus infinite to plus infinite. This summation I am going to split like integral n is equal to minus infinite to minus 1 Cn e to the power Jn omega naught t plus C naught. I am writing 0, n is equal to 0 term as C naught, and plus summation n is equal to 1 to infinity Cn e to the power Jn omega naught t. Just the summation is written like this: minus infinite to minus 1, 0, and 1 to infinite. Okay. Now what I am going to do, this x of t I am writing as, so C naught I am writing separately, plus here n is minus infinite to minus 1, I am making it as a plus 1 to infinity, plus 1 to infinity. Here we have Cn, it will become now C minus n, right or not? Both are same. And e to the power Jn, it will become minus Jn omega naught t, plus again we have summation 1 to infinite, the second summation as usual, Cn e to the power Jn omega naught t. I think this step is clear. So here we have negative n values, we make it as positive, and here we have n, that is minus n, here we have n, that is minus n. Then both are same, no change. So here if you see summation 1 to infinite, summation 1 to infinite, we can take it as common. So summation 1 to infinite is common. Okay. Then C minus n e to the power minus Jn omega naught t plus Cn e to the power plus Jn omega naught t. So I am keeping bracket. Right? Now So I'm going to use this exponential e power j theta according to Euler's rule or formula. E power j theta is, what is e power j theta? Cos theta plus j sin theta. And e power minus j theta, if you have minus j theta, then cos theta minus j sin theta. So this point we are taking now. Okay. So C naught plus summation n is 1 to infinite c minus n. So here it is like e power minus j theta. So cos n omega naught t minus j sin n omega naught t. Okay. And plus cn. Here we have e power j theta. So cos n omega naught t plus, you get here plus j sin n omega naught t. N omega naught t. Close the bracket. So just e power j theta I am using, or I am writing cos theta plus j sin theta. So what I am going to do, here we have cos function, here we have cos function common, or cos theta common, or cos n omega naught t is common. And similarly sin function common. So that is the next step we are going to do. So in the next step, x of t is equal to c naught plus summation 1 to infinite cos n omega naught t is common. Cos n omega naught t is common. So here you get c minus n. Just before going to this step, I will take once again the previous step. So what is the previous step we have, that I write again. So x of t is equal to c naught plus summation n is equal to 1 to infinity c minus n e power j, e power j is cos theta, right? So cos n omega naught t minus j sin n omega naught t, right? Plus cn cos n omega naught t plus j sin n omega naught t, sin n omega naught t. Okay. Now cos functions, here we have cos n omega naught, taking common. So that is the step next. So x of t is equal to c naught plus summation n is 1 to infinite, take common cos n omega naught t common. So we get here c minus n, and here we have c n. So plus cn. And similarly sin n omega naught common, sin n omega naught is common. So here we have c minus n, j also you can take common. So in both we have j. So here we have cn, right? Here we have minus c minus n. Okay. Now we have trigonometric Fourier series. We know trigonometric Fourier series. What is trigonometric Fourier series? X of t is equal to a naught plus summation 1 to infinite a n cos n omega naught t plus b n sin n omega naught t Okay. Now compare these two. Suppose this is 2 and what we have 1. So compare 1 and 2. On comparing 1 and 2, what we get? Compare 1 and 2. So we get, these are the results we get. A naught is C naught, right? A naught is C naught. A naught equal to C naught. This is our first comparison or first relation. Another relation. So here cos n omega naught t, cos n omega t. Here we have Cn plus C minus n. Here we have An. So this is the second relation. So An is equal to Cn plus C minus n. Cn plus C minus n. And another relation. Here we have sin n omega naught t, sin n omega naught t, Bn. So Bn will become J Cn minus Cn. So this is the relation between trigonometric Fourier series and exponential Fourier series. Okay, right? And we can also write Cn in terms of An and Bn. Here An in terms of Cn and C minus n. We can also write Cn in terms of An and Bn. So how to do that? So here Bn is equal to Jcn minus Jc minus n. So what I am going to do, I am multiplying An by J. So J into An equal to Jcn plus Jc minus n. Right? Now we have Bn. What is Bn? Jcn minus Jc minus n. So An is multiplied by J, right? Then Bn I am taking as it is. So by subtracting these two, we get C minus n, right or not? So subtract these two, subtract minus. So Jcn minus Jcn cancel. So we get 2Jc minus n is equal to Jan minus Bn, right? Jan minus Bn. Now C minus n is equal to, next page. So what we have? 2Jc minus n is equal to Jan minus Bn. So we want C minus n. So send 2J right side. So C minus n is equal to Jan minus Bn by 2J. This we can write as C minus n is equal to JJ cancel. Okay. With An I am telling. So An so 1 by j is minus j, you can take 1 by j is minus j. C minus n is equal to, just I am simplifying this. C minus n is equal to, suppose if you take j common in the numerator, so An minus Bn by j. Bn by j is minus j. Bn by 2j. So here jj get cancelled. So this is the C minus n. Similarly Cn also we can do. So what is C minus n? An plus jbn by 2. This is the C minus n. Similarly, Cn we want. We want Cn. So how to get Cn? How to get Cn? So previously we subtracted. Now to get Cn, what we need to do? Addition. So what we have actually? We have JAN is equal to JCN, J minus Cn plus JCN, and we have Bn. What is Bn? What is Bn we have? So Bn is equal to I think Bn is otherwise Cn we want, right? So already we have Bn. What is Bn we have? By comparing Bn we have. What is that Bn we have? J C minus n, J C minus n, minus n, I think it is plus n. So C plus n, J C plus n minus n. This is the Bn we have. Okay. So now split this. So Bn is equal to J Cn minus J C minus n. Right? Now we want Cn formula. So we need to add this. You take as 1. This you take as 2. 1 plus 2 you do. You get the Cn formula. Simply. So what is 1 plus 2? Bn plus Jan is equal to here minus JCN, C minus n plus JC minus n. Cancel, you get 2JCN. Simply 2JCN. Now we want Cn formula. That is why I am writing Cn is equal to Jan plus Bn divided by 2J. So same we can do simplification. J common you can take. Here An minus JBN by 2J. So JJ get cancelled. What is Cn we got? An minus JBN by 2. So this is the important relation, Cn and C minus n. And if you take the magnitude of Cn, what is the magnitude? Under root of An square plus Bn square by 2. And if you take C minus n magnitude also, same, under root of An square plus Bn square by 2. Magnitude I am writing under root of real part square, imaginary part square by 2. Here also under root of real part square, imaginary part square by 2. So let's write the summary what we have done till now about exponential Fourier series. So exponential Fourier series definition is x of t is equal to summation n is minus infinite plus infinite Cn e power jn omega naught t. Right? And we can also write like this: C naught plus summation n is minus infinite to plus infinite, but n is not equal to 0. But already 0 term we have written separately C naught. Right? Cn e to the power jn omega naught t. Summary I am telling. What is Cn? Exponential Fourier series coefficients. The formula for Cn is 1 by t integral 0 to t x of t into e to the power minus jn omega naught t dt. The simple formula. Okay. And we have relation, just now we have seen Cn is equal to An minus jbn by 2 and c minus n is equal to an plus jbn by 2. Okay, and magnitude of cn is equal to under root of an square plus bn square by 2. C minus n magnitude is also same. Okay, right? And this is the relation between trigonometric Fourier series and exponential Fourier series. So by this, we are closing the topic or session. We meet again. Thank you all.